This is question number 21 of 0620, paper 2, May, June, variant 2. Question 21. Lithium and potassium are metals in group 1 of the periodic table. Lithium has the melting point of 181 and the density of 0.53 gram per centimeter cube. Which row identifies the melting point and the density of potassium? Okay, so as we see in group 1, friends, in the physical properties, the melting point and density. If we see the density for the group 1 elements, their size increases because the number of shells increases, the size increases, so the density will also increase. As we go down the group, the density increases because the density is the measure of heaviness of the object and how much volume they are occupying. So its density, because lithium and potassium, we have lithium, sodium, and then potassium. So potassium is after lithium. So that means its density is going to be greater than lithium. Now, as for the melting points, because when we go down the group 1, they become softer and softer. The particles, the electrons become far from each other, they go far from each other, they go far from the nucleus, central nucleus. So they become softer and it will be easier to lose the outer shell electron. The force of attraction weakens between them. The reactivity increases. They become more vigorous in their reactivity. So they get softer and the melting point decreases. It becomes easier for them to melt. Melting point decreases. So the melting point of potassium, which should be less than that of lithium. So the answer is B. Which statements about transition elements are correct? Now, transition elements are metals. They are typical, they have the properties of the typical metals, like they are very hard, they have high density. So this one is wrong because the transition metals have high density. They form ions with variable oxidation state. Yes, I do. Variable oxidation number state. Oxidation state, that is the special property of transition elements, that they form variable oxidation states. They have high melting point. Yes, because the transition metals are very hard. They have high melting points. It's very difficult to melt them. They need very high temperature to overcome the attractive forces between the particles and to melt. They form only colorless compounds. That's wrong because transition metals can form colored compounds. That's all. This is also like a different property of transition elements, that they form colored compounds. So option 2 and 3 are correct, which makes the answer C. In the next question, 23, which statements describe the elements in group 8 of the periodic table? Now, for group 8, we all know that group 8 are noble gases. They are inert, they don't react, unreactive. They don't form compounds. Their atoms, number 1 statement is their atoms have full outer electrons. Yes, that's correct. That's make them inert. They don't need to react because they don't need electrons. Their outermost electrons are there. All the shells are full. They are unreactive metals. They are unreactive. This part is correct, but this part is wrong because they are not metals. They are non-metals. Noble gases are non-metals. They are monoatomic gases. Yes, it's correct. They are not diatomic. They're monoatomic. Mono means one, so they can exist as one atom. Like helium can exist like this. Neon can exist like this. Argon. It can also exist like this. They're not diatomic. They are not diatomic like halogens. Like halogens are F2, Cl2, I2, Br2. So the halogens exist in diatomic form, in 2 atoms form, but they exist in 1 atom form. So this means 1 and 3 statement is correct. A is the correct answer. Okay. Number 24. Four metals Q, R, S, and T are each added to separate samples of water, steam, and dilute hydrochloric acid. The results are shown. Which statements are correct? Now, here you have the results. Observation that when they react with water, what happens? When they react with steam, what happens? When they react with hydrochloric acid, what happens? So, the difference between water and steam is this is simple cold water, and the steam is considered as warm water or hot. Which statements are correct? Number one, R is the least reactive metal. R is the least reactive metal. Okay, now as you can see, for the R, it does not react with water, it does not react with steam, it does not react with acid. In water and acid, there is hydrogen, hydrogen, hydrogen. In water also it's hydrogen H2O. In steam there is what hydrogen. In acid also there is water, hydrochloric acid. So hydrogen, hydrogen, hydrogen. The metal has to be more reactive than hydrogen so that it can react with water, steam, and hydrochloric acid. It has to be more reactive than hydrogen. But it is less reactive than hydrogen. It is showing no reaction with these things. So it means it's least reactive. Rest of the rest for the rest of the elements, as you can see that they show some reactions. There are some reactions, but for the R, this completely no reaction at all. T could be potassium. Okay, let's see. They're saying T could be potassium because it is showing fast reaction with water. Potassium is a highly reactive metal. Yes, it's a high reactive metal, so it shows very strong reaction with simple water. Yes. It explodes with steam. Yes. It explodes with hydrochloric acid. Yes. So it could be potassium. S is more reactive than Q and R. Now R is the less reactive, so obviously S will be more reactive than R. But is S more reactive than Q? Let's see. Let's find out. S is showing no reaction with water. Q is slowly reacting with water. This means Q is more reactive. Also, S is reacting very slowly with steam, but Q is giving fast reaction with steam. With hydrochloric acid also, S is slow reaction, and with hydrochloric acid, the Q is giving fast reaction. It means Q is more reactive. But here in statement 3, it's written S is more reactive than Q. So no, Q is more reactive than S. Number 4, metals generally react faster with steam than they react with water. That's correct. Because metals or all the other substances, if they react with steam or if they react with anything which is hot, the reaction will be faster as compared to anything which is colder. So yes, metals react faster with steam than with cold water. So the answer is 1, 2, and 4A. Question number 5. Metal X act as a sacrificial metal to prevent iron from corroding. Now, sacrificial metal. If it is sacrificial metal, so that means that metal X it has to be more reactive than iron. If it is more reactive than iron, then it can do the sacrificial protection of iron. It sacrifices itself to protect iron. It should be more reactive than iron. Metal X does not act as a sacrificial metal to prevent aluminium. So, it does not react aluminium, that means it is low reactive than aluminium. It is low reactive than aluminium because it is not protecting aluminium. So the metal X could be between aluminium and iron. It should be low reactive than aluminium, but it should be more reactive than iron. So what it could be? It could be copper. No, copper is low than iron. Magnesium. No, because magnesium has more reactivity than aluminium. Silver. No, silver is low reactive than iron. Zinc. Yes, because zinc comes between aluminium and iron. So zinc can protect iron, but it cannot protect aluminium. Number 26. Which equation represents the reduction of a compound found in hematite in the blast furnace? Reduction, as we studied in the previous video, reduction is either the gain of electrons or it's the loss of oxygen. So we have to see that whether that compound is gaining electrons or maybe it is losing oxygen. What element is present in hematite? Hematite is the ore of iron. So the compound which is present in hematite is Fe2O3. And the equation D can be a reduction equation because here the iron oxide is becoming iron. It's losing its oxygen. It's losing oxygen. So that means it's reduction. Iron oxide is turning into iron. It has lost its oxygen to carbon monoxide. So this is a reduction reaction. Number 27. Which statements about treatment of domestic water supplies are correct? Treatment of domestic water supplies. Filtration is used to remove insoluble substances from water? Yes. Filtration is always used for insoluble solid in a liquid. If we have a solid in liquid mixture, means solid is insoluble in a liquid, then we can perform filtration on it. Then insoluble solid will go into the residue on the filter paper and the liquid part will go into the filtrate. Next one, sedimentation is used to remove soluble substances from water. Now, sedimentation is when the particles come together, they coagulate, they form a heavy particle and they settle down at the bottom of the tank. So when the small particles coagulate to make a big particle, or they become heavy, and then they settle down at the bottom. So sedimentation does not remove soluble substances. It is also for insoluble substances, but which are very, very small. So this is not correct. Number 3, carbon is used to remove taste and odors from the water. Carbon slurry. We use carbon slurry in the treatment of water. Now carbon, as we know that carbon in the form of a charcoal, carbon can absorb substances. It has the property to absorb the chemicals. So carbon is used to absorb all the compounds which are responsible for bad or odd odor or taste. So yes, chlorine is used to lower the pH of water. No, chlorine is used in the treatment of water, but not to lower the pH. Chlorine is used to kill bacteria or to kill microorganisms in the water. So the answer is A, 1 and 3. Which statement about water is correct? Water turns anhydrous copper sulfate from pink to blue? No, because anhydrous copper sulfate is white. It turns anhydrous copper sulfate from white to blue? Yes. It turns cobalt chloride paper from blue to white? No, Because cobalt chloride paper is blue in color and it changes into pink in the presence of water. It turns cobalt chloride paper from pink to blue? No. It turns cobalt chloride paper from blue to pink. So B is the correct option. Number 29, cupronickel is used to make coins. The arrangement of atoms in a cupronickel is shown. You can see from the diagram that this is the diagram of an alloy. So cupronickel, which kind of substance is this? It's an alloy. Where an alloy is when different size particles are incorporated or they are added into a metal structure which jams or disturbs the structure, making the layers unable to move or slide over each other, making it hard. So here we have copper atoms and nickel atoms. They are mixed with each other. So the mixture of metals is called alloy. Which physical properties are typical of all metals? Now, for all of the metals, they are good. They have good heat conductivity. They have low density. And they are malleable. All of the metals are malleable. All of the metals are good heat conductors. But not all the metals have low density. Some metals have low density, like group 1 and group 2. These metals have low density, but transition metals are hard, so the transition metals have high density. So the answer is 1 and 3. Option B is correct.